Hi, everybody, and Derek from SparkFun here. Thank you so much for joining us for our live Ask Me Anything. Today, we're going to be joined by Dustin Franklin from NVIDIA, and we're going to talk all about AI and machine learning around the NVIDIA Jetson Nano. With that, let's bring on Dusty. There he is.
Thanks,
hey,
Derek. Hey, everyone.
Not a problem.
Happy to be
You want to
here.
introduce yourself a little bit and tell us a little bit about yourself?
Yeah, sure. I'm from the Jetson team. Technically, I'm a developer evangelist, but all that really means I work on technical projects and I'm really involved in the community. You might have seen me around the forums or GitHub, places like that. So always happy to help out, and yeah, really happy to be here and love answering your guys' questions.
I know in the past, over the past, 2 years since the Nano's been out, you've kind of been my go-to for answers for my questions, as I've been working with the Nano, both the original and the new 2 GB. Before we dive into the more technical questions, I do have some rapid fire questions for you to kind of break the ice a bit. You ready?
Oh, yeah.
Okay, here it comes. So first idea that comes into your mind or first response. Video games or board games?
Board games. I know. Since I've had kids, I haven't played video games in so long. They like board games. I know that's bad.
Star Wars or Star Trek?
Star Wars.
Thank you. You can stay on now. And last but not least, toppings on your pizza.
Sausage and pepperoni.
Neat guy. From Pittsburgh, yeah. Right? So that kind of makes sense.
That's right. Yeah, I am from Pittsburgh.
Perfect. So, I mean, a couple of questions that I have before we jump into those people that are the questions from the live audience, I guess you could say for now, the COVID live audience. How did you get into AI and machine learning? I mean, it's a relatively new technology, and so can you talk a little bit about where you started your career and how you got into working both for NVIDIA, but also just started using and applying machine learning?
Yeah, sure. So, I mean, Pittsburgh, there's a lot of robotics going on here because of Carnegie Mellon and all these startups. So, you know, after I graduated, it was around like 2010 or so, and you know, was working in that field and doing a lot of computer vision, and I'd always been into GPU. So even before CUDA, I was doing like rendering engines, and so that's why it's even more ironic that I don't really have time to play games myself anymore. But then when CUDA came along, I got really interested in all that compute horsepower that was just available in my PC. So I got more into that and computer vision side of things, doing things like OpenCV or just you know, optical flow based CUDA kernels and everything. And it went along like that for a while. Eventually, I started working for General Electric. They were making these mini Tegra modules. This was, you know, before even the Jetson TK1, which was like the first Jetson board. But it used to be NVIDIA. They didn't actually make the Jetson modules themselves. They had other third parties like us doing it. And then eventually NVIDIA started making the Jetson products, and the Jetson TX1, which was the first one that was an actual deployable module that plugged onto the dev kit carrier. And then I came over at that time. And even then, I think that was like 2015. And I still was just doing traditional computer vision stuff. But then all the machine learning craze happened, and at that time it was like a lot harder to get started, and I remember even having a lot of challenges myself. It seemed like you needed like a PhD or master's to understand all this stuff. Everything was in cafe with these really cryptic long proto text files, and but since then, with like TensorFlow and PyTorch and all the tutorials that have come out, it's really a lot more approachable and friendly and easy to get started with.
For those of us that are a little bit new to probably at least the NVIDIA technology, if not machine learning, can you talk a little bit, because you referenced it a little bit, CUDA. So can you talk about a little bit about what that is for those that don't know what it is?
Sure, yeah. CUDA really underpins everything. It takes all of these hundreds or thousands of GPU cores that you have and takes the code, distributes it across all these processors. And CUDA code, it looks very similar to C or C++. It's just parallelized. So you basically supply CUDA with this function, and it calls that function once every time per thread. And so, for example, let's say you want to process an image. You would launch the number of threads as pixels in that image. So if you have a 1920 by 1080 HD image, you would launch a grid of threads that's 1920 by 1080. Each thread would load a pixel from that image, do some processing on it, maybe communicate with other threads, like if you're doing some averaging or a convolution filter that depends on neighboring pixels, and then outputs that pixel back in. So there's a bunch of simple examples to it. It can also get very complex to do. And I still write a bunch of CUDA code, but it's much simpler than it used to be. It's all for like color space conversion or really simple things. Because nowadays, there's so many CUDA libraries out there that, like cuDNN, for example, that does all the machine learning stuff, which are then integrated into the machine learning frameworks, that you never really have to ever touch CUDA code yourself. You just really benefit from the advantages of it. But it is kind of interesting to play around with if you like that kind of thing.
Yeah, I haven't gotten that deep. Maybe at some point with playing around with things, but yeah.
There's also other like PyCUDA. You can write CUDA kernels from Python code, or there's CuPy, which is like a CUDAized version of NumPy. So there's a lot of other helper libraries out there to get started. But far and away, even myself, it used to be writing tens of thousands of lines of CUDA code for like optical flow or stereo depth matching. But now it's just basic stuff like the color conversion or formatting stuff or simple line rendering. So it's pretty easy going.
Sweet. You referenced a few of the the TX products in your intro. Why, when we have the NX was announced and released a couple months ago, as well as, but now why the Nano? So why is NVIDIA going down this route of kind of the more affordable, both the original and as well as the newer 2GB, the more affordable and approachable product line?
Right. Yeah. Well, I mean, just like we had been working to democratize the tutorials around AI, make it easier to start it. The other end of that is just making the hardware much more accessible, easier to use. And so we had an opportunity to make a lower cost product from the previous generations, and like basically shrink down that Jetson TX1, TX2 form factor, make it a much smaller kit. It used to be a mini ITX board. Now it's a much smaller little carrier board to use, and uses the SD card, so it's easier to get started with. You don't need to flash it from another PC or an Ubuntu PC. You can just put in the SD card pretty much. So yeah, and we've seen a huge increase in the number of developers that are able to get started on it, which is good because I mean there's so many opportunities out there growing in this field, not only robotics but everything that AI has influenced and touched. So it's a great future to get started with, and you can learn on the Nano and then scale up to cloud systems or whatever type of future opportunities you're interested in.
Yeah, I know that the Nano, the 4GB, was my first entry point into NVIDIA products. And so I've had like this nice cushioned landing into machine learning and AI. And I just know that a lot of the frustrations that a lot of people have had is not something that I really, I guess what I'm trying to say is I really enjoyed kind of that being my introduction. I feel like a lot of how it used to be done the hard way has been kind of removed and simplified, both in terms of example code and things like that, starting on the 4GB, but then jumping into how things are working on the 2. Can you speak a little bit about some of the differences with some of that onboarding, moving from more of a SD card images to Docker and containerized example code? That's one thing that struck me as soon as I got hands-on with the 2GB. Your content, more than the hardware itself, the content and how you delivered it to people to get started was very different. So if you can speak to that a little bit, that'd be great. And then we'll jump into the live questions after that.
Yeah, sure. So essentially, yeah, we used to make SD card images like the DLI Institute courses would have an SD card image. JetBot had a whole SD card. And that was really just a way to avoid the frustrations of having to install all that stuff, because machine learning applications, typically they have a lot of dependencies. The frameworks are very big, but make no mistake, machine learning is not about cutting your teeth on TensorFlow. So we started by making these containers available for all that, and the Python pip wheel installers. So you can literally just download the container, don't have to worry anything about how to install it, and just go and start running things. And then as time went on, we started basing our other examples and tutorials off of those containers. And the reason we migrated from the SD card images is those images typically get stale. They're like hard to refresh with the frequency of Jetpack updates that come out. And you also need to maintain multiple SD cards. So with our new tutorials and the containerized versions of them, you can have all of them loaded on one system, and have all of the containers on there at once, which makes it really easy. And the containers kind of flow into the larger NVIDIA software as well, because there's containers from NGC for the PC or server systems. If you do have a PC with a GPU in it, you can get those versions of containers for that, run the same thing there. And that's really the nice thing about the Jetson, as you alluded to as your first entry into NVIDIA products, is it runs all the same stuff. It runs CUDA, all the Jetpack libraries like cuDNN and TensorRT. So you can take all that code and the containers and run them on other systems as well, which is great for a learning environment, because you just get this little tiny supercomputer, but that teaches you how you would program a real system out in the world.
Yeah, and speaking of teaching, one of the questions that we had from the audience is, are there any online courses you recommend for learning more about embedded systems, AI and machine learning specifically? And you talked about the DLI course, so I'll let you expand on DLI and some of the courses that NVIDIA offers.
Oh yeah, absolutely. So with the 2 GB, we launched this certification program. So you can become a Jetson AI specialist, or if you're an instructor, you can become an AI ambassador. And basically you just take a few of these online courses that we have and tutorials like this Getting Started with AI on Jetson Nano, and then there's the JetBot, which you guys make one of the JetBots. It's just like a little autonomous rover that has the Nano on it, and you can train the models through IPython, Jupyter Lab notebooks and things like that. And then there's the Hello AI world that you can use to make your own projects. So yeah, you go through that. We have like YouTube screencasts for all of that, and you go and make your own project, submit it, and then you get certified. And there's a lot of people that have been happy with that to like build up their resume and such. And then more on like the actual university course side, there's a number of university courses out there. Like most recently we partnered with Duckytown. They make a little autonomous robot with like a full semester long course and all the contents and everything. So if you're an actual professor, you can go off and teach Jetson that way. And then there's a number of other ones, like these autonomous RC cars are very popular because there's like a competitive aspect to that, and all the students are training and racing their cars to see who gets the fastest lap time. So there's courses from MIT and UPenn and University of Oregon that do those, and there's a lot of content and courses out there if you're interested to learn that stuff.
Yeah, I know that Duckytown, because I've talked with them as well and checked them out. It's one of those things that it's an interesting concept and piece of content for learning, because it's not only about the driving aspect of this. That's a big part of it, but it's also how do we apply AI to other parts of the city? And you kind of do this. It's a little model city, right? And you're applying the AI and machine learning to the robots that are driving around, but also there's challenges for how to apply it to the stoplights, how to make parking spots smart, all that stuff. So it gives more application points for machine learning and AI beyond just kind of what most people think of in terms of the application of driving this car and stopping when somebody walks in front of it, and knowing when a light is red or green. So it kind of expands that idea.
Yeah, absolutely. And a lot of the ones that have parallels to self-driving cars are popular because that's a huge market for engineers in the future, and there's a lot of folks out there that want to get trained in that technology. And it is all very similar. Self-driving cars is just really a bigger, more expensive version of these little robots. They have the same sensors, cameras, LiDAR. They have just a bigger version of this same processor in them, and have to do very similar algorithms. So there's a lot of opportunities out there to get started if that's what you're interested in.
Yeah. And again, during prep, I'll just let everybody know that I had this question in my head, and this is something that's always kind of, and we have a similar question from a viewer as well, but the question around a lot of the input that you see for machine learning right now is around a camera. Can you elaborate a little bit on what are some other interesting sensor inputs that we can look at in terms of having machine learning applications, right? We talked a little bit about temperature, but there's also audio, and I think that that's one that goes pretty straightforward when we live in the world of Alexa and things like that. Can you elaborate on what are some other inputs that maybe those of us that are looking for an application or trying to think of applications can start to latch onto?
Sure, yeah. So yeah, cameras probably the most popular for robotics and video applications, obviously, but LiDARs, millimeter wave radars, ultrasonic sensors are also very popular in autonomous robotic applications. And a lot of those are processed the same way through these sensor fusion models. The bandwidth on them is just typically lower than video. So video can actually be quite challenging because you have a 1080p stream or multiple streams coming in, so it takes a lot of horsepower to handle that. But obviously on the voice side for automatic speech recognition from audio and NLP, and then the other side of that, text-to-speech or speech synthesis, that's also growing in popularity, not only for the home assistant applications, but also in robots as well, because they have to actually interface with folks out in the field, like these last mile delivery robots that you see popping around in cities like San Francisco and Washington, D.C., and will start being more widespread, but there's have to talk and interface with people when they make their deliveries. So there's a bunch of cool models out there that run those, like the deep speech model, or NVIDIA has a bunch of networks through this, what's called the NeMo toolkit. So you can do ASR on your Nano using neural networks, and it's actually really good. And then earlier this year with the NX, I played around a lot with the BERT model, which was really a lot of fun because I was able to make a chatbot that basically took these ASR models. It was called QuartzNet, which is one that came out of NVIDIA Research, and then basically just pipe that text over to BERT, and then you can make an interactive chatbot where you gave BERT some backstory on a bunch of topics, and then it was able to respond to you intelligently, all running on this little Jetson device, and it was really cool to see in practice. But then we've also seen folks out in the community, they just are doing general signal processing on it. For example, there was a recent project that this guy hooked it up to his power appliances and was predicting the energy consumption of his home, and it was actually for a solar panel energy prediction output. And it is basically just doing one-dimensional LSTMs, or recurrent neural networks, to predict a signal into the future. And there's a bunch of folks in radar community or signal processing that are doing very similar things, both for classification, like classifying what signals coming in, and for prediction. And then if you have a bunch of signals, you can use autoencoders and kind of determine when signals are out of whack. Like in automobiles or such, they will try to assess early failures of components based on vibration sensors or temperature data. Or when I worked at GE, they have all those jet engines are outfitted with tens of thousands of sensors, and they can tell when one is deviating, and they might need to replace a part soon. And all of that is done with machine learning prediction.
Sweet. Kind of, so to follow up on that a little bit, because one of the questions is, one of our customers or people viewing just got the SparkFun spectral breakout sensor. What would be the best path to start with using those libraries for it? So like if I was to, obviously I have this sensor, I'm gonna have to collect a bunch of data. And with that spectral sensor, I'm assuming it would be data in maybe a CSV format. Can you maybe elaborate on that? I mean, it's very, we could say you could be a very similar data stream to like a.
Is it like a multispectral camera, or what?
Yeah.
What does it do?
Yeah.
Yeah. Okay.
Yeah, because the one I'm thinking about, there's 3 spectral sensors on it, so you're getting 3 different ranges.
Oh, okay, but it's different than RG and B, I take it. Like an infrared or okay, yeah. So you can do very similar things. In fact, you wouldn't even, since it's 3 sensors, you wouldn't even need to change the network architecture. So you could just train a Google Net or ResNet to perform classification or detection on that. You would need to collect your own data set for doing so, but it really wouldn't be any different. In fact, those networks, they don't even know they're getting image data. It's just a stream of tensors to them, and they correlate it with what output you feed to them. So, for example, with COVID, we did some projects using infrared cameras, which are just single stream or single channel. And it was no issue to detect people's temperature through machine learning with those, because the training data was just single channel as well. In the past, I've worked with hyperspectral sensors that they might have hundreds of bands in them. And it's really cool because you can actually determine what material you're looking at based on the spectral signature of it. So in that case, you would just modify the inputs to the model to, instead of having 3-band input, to have, 500 band input, or however many channels your camera had. Obviously, the challenge is collecting all of the data for that. But I have started to see some multispectral and hyperspectral machine learning data sets out there, which is really cool to see. And yeah, I really look forward to when you can actually get a full-on like focal plane array camera in multispectral or hyperspectral for decent cost, because they're like pretty magical what those can do.
Yeah. Do you have a good, I guess, place to point people for landing to just start to play around and look for different models that are out there? It's obviously very few of us actually want to or have time to build our own. So
yeah, let me share my screen real quick here. So as far as the Jetson goes, we have this what's called the Jetson Zoo. It's just a page that I maintain on this eLinux wiki. And not only does it have all of the frameworks that are pre-built, and you can install in here like PyTorch and Caffe and MXNet, and these are the popular ones like Keras and whatnot. You can install lots of others as well in the Pinterest too. It has this popular model zoo on here for predominantly classification, object detection, and segmentation. Pose estimation is also very popular. But the short answer is you can also go to like the PyTorch model zoos or the TensorFlow ones, because you can just run basically any models on Jetson. Since the processor itself, we don't need to be using like TensorFlow Lite or some special optimizer for it. You can just run the models through TensorFlow. So a real common thing, just go to GitHub, search for what you're interested for. You want to find some model to use. There's a lot of people doing like the latest YOLOs, YOLO v4, v5. So it's all on there. The ones that I just showed you, those are the ones that I personally use and test through what's called TensorRT, which is our inferencing accelerator library. So if your model is able to be run through TensorRT, you will get better performance through it. But you also get good performance just by running through PyTorch, for example. And And TensorRT does support a lot of models, even with RNN and LSTM in them. And the easiest way to do that is just to export the model to ONNX, which is like this open neural network exchange format. So I do a lot of that. I'll train a model in PyTorch, export to ONNX, import it to TensorRT, and then you'll get, 30 frames per second or more, depending on how complicated the model is. And even do like the training right there on board the Nano in PyTorch, which is just my preference. People do a lot of TensorFlow also.
Sweet. Yeah, it's good to know. I'm going to look up ONNX because it's one of those things where it's, especially doing some of the demo work and things like that, is like, okay, I have this, I need to be able to export it to be able to use something else, right? And I just don't know the environment enough and to know, like, okay, I gotta, if this is looking for something that's specifically from PyTorch, but I have this, I don't know enough to be able to plug the two together yet. And I think that's one thing that for my own learning is like, how do I translate maybe one model into something that can be usable in another?
Yeah,
framework.
So ONNX is like the fully independent way of doing it, because you have it in PyTorch or TensorFlow, export to ONNX. It's totally independent of the framework at that point. So when you go to actually run it, you don't need PyTorch or TensorFlow. So you save a lot of memory, But my colleague made this tool on GitHub called Torch to TRT, and basically that skips over the ONNX and runs it straight from PyTorch to TensorRT with the same API in there. So you basically just make like a little function call from his library, and then the model is transparently transferred to TensorRT and magically runs much faster for you. So there's a bunch of like little optimizations that you can do. Generally, you would get to that after you do like your initial prototype or proof of concept. Again, I spent a lot of time just doing PyTorch or TensorFlow, or it's totally acceptable just to start in those. But if, let's say, you want to be running on like multiple streams, or you want to get it as fast as you possibly can, then there are alternative approaches out there that can further improve your performance.
Sweet. Yeah, I think you just saved me a bunch of time. But less about me. Actually, two people have asked this so far, so I'm going to ask you. Where it's a little bit of a step backwards here from where the conversation went. What IDE and programming language do you recommend with working with the Nano? It's the questions around NVIDIA dev boards, but I would assume they're talking about both versions of the Nano.
Sure, yeah. Well, personally, like if I have a display attached, I'll just open gedit and the terminal and do it that way. And a lot of this is in containers and such as well. So I do a lot of that. I understand that's not an IDE, but there's a lot of folks in the community that use Visual Studio Code. And that was before I think Microsoft even made the ARM binary available for it. So there was folks that were building it to run on their Jetson, and that seems to be a popular IDE for it. But now it's like pre-built, and you can just install it much more easier. But these days, there's like so many Jetsons out there. I have like a bunch of them on my desk. Mostly, I just use like this MOBA Xterm from my work laptop and be able to maintain all these different SSH sessions in. But pretty often I do have to like connect a display to test camera feeds and things like that. And
then from a language perspective, I know that in the Hello AI, you give the two options of C and Python. Which one do you prefer? Which one do you use the most?
Good question. So the whole library is implemented underneath in C++. And then I have these Python bindings for it, which is how the performance is the exact same from Python or C++, because most of the heavy lifting is all done in C++. Maybe a year or two ago, I would have told you C++, but I do mostly Python these days. I'm always like tweaking PyTorch scripts and improving those bindings, and it's obviously a lot quicker to author code in. So I guess the short answer is, if you have all of the stuff you need in those high performance C++ backends, then I prefer just to write the interfaces in Python because it's so much quicker. But if you need performance and heavy chunks of processing done, then I don't hesitate to actually improve my back-end code that does all of that stuff, maybe write another CUDA kernel or two and do things. So more often than not, I will work on the C++ side of things and then write the Python binding for it so that I can just use it from Python, but still get native level performance.
And I know from an IDE perspective, in terms of if you're getting started, this question kind of stems from, I think, that Jupyter Labs and Jupyter Notebooks could, I guess you could say, be an IDE of sorts for them in terms of looking at Python. I think, can you run C from it as well? But I mean, all of your stuff is...
Yeah, there was an extension for that we found some time back, and I think that was before I even added my Python bindings. But a lot of our tutorials, like the Nano DLI and the JetBot, those are all fully in Jupyter Lab, and for all intents and purposes, it is a Python IDE. I don't think it necessarily has like code highlighting, or it doesn't have like the jumping to definitions and stuff like that, which is really what separates a real IDE and makes your life a lot easier there. But Jupyter, it's great for experimentation, and you absolutely can run it on like the Python side of things. So it seems easiest that way.
Yeah, I mean, it was really great from my first experience of getting into this, because it removed some layers of complication for me, and allowed me to kind of jump in and get quicker to awesome in a lot of ways. I know that, though, as I started to grow from that, if you think of Jupyter Labs as the training wheels, as I started to grow from that, I was finding myself very difficult trying to separate out some of the widget code that's in Jupyter Notebooks and getting my code to function on its own on Python outside of Jupyter Notebooks. And so that might be something to look at in the future, is kind of like, what are those next couple of steps?
I know exactly what you mean. Yeah, because you have the notebook there and all the cells, but if you really want to like modularize that, essentially you have to copy and paste each one into a Python library and do it. So, for example, the Nano DLI and the JetBot, those are all in there because they're remote and headless and things like that. But the Hello AI world is like its own library that you can use either inside or outside of Jupyter to make that your life easier there. And we're looking at modularizing the code for JetBot as well. So I totally agree that Jupyter is great for experimentation, for getting started, but there does come a point where, like you said, you have to take the training wheels off and actually start writing a more organized program structure with like Python modules and things like that, once your application becomes sufficiently complicated, right? Because then if you don't, you just have a spaghetti mess of these IPython notebooks that it's not really instilling good coding practices, and along those lines, generally folks, they'll work a lot in IPython, but if they're into robotics, maybe then we start moving more to like ROS or things like that, are much more modular based on graphs of nodes, and you can definitely learn to use that. And then ROS has great GUI tools too, like RViz, and but there's definitely benefit in both types of approaches.
Yeah. It's been really fun to play around with it. I authored some of my first, I would say, labs notebooks around using some of our quick boards with the Nano, and so it was very, it was fun to really author those, but then to take like the sensor output and visualize it some way other than just a list of numbers, right? So I can get it to list like a print function, but then it'd be like, hey, here's a different way to visualize it in notebooks. And so if you were looking for just that, like, hey, here's some sensor output, or if I want to control something with a very simple button click from a software interface, yeah, it seems like that was a really good tool to use at that surface level, and then go from there. So that was,
yeah.
I'll be playing around with making.
Yeah, far and away Python is quick. Like you want to quickly make a chart or something, just import matplotlib, and whereas it would probably take you an hour or two to get the same thing in C++. So it's definitely a lot faster to get going. Even if you're outside of IPython, there's so many tools that you can use to visualize things.
Question for you: how do I use Canbus with the Nano? So I don't think the Nano has. Does it have a Canbus connection?
I don't want to misspeak. I don't think the Nano does not have Canbus controller on it, because the Nano is based on TX1 SoC. It was only until the TX2 that there was a native Canbus controller in there. And then the NX, the Xavier NX, does have native CAN bus. But there are a bunch of people in the community that they attach I think it's like a SPI to CAN or I2C to CAN, and add the CAN transceivers on there. I think it was probably one is like the MCP 2225 or 2525 or something like that. But there are a lot of folks in the Nano community that have attached CAN bus to it. So if you check the forum, you'll find a bunch of posts doing that. It seems like the SPI to CAN transceivers are the most popular ones.
Yeah, and we do sell a couple of options as well. And then we also do have actually a microcontroller dev board that you'd probably be able to get the two to connect and talk between the two. It's the CAN 485 dev board.
Oh, it uses like RS 485?
Yeah. Yeah,
okay,
I think so.
Cool.
I haven't.
Yeah. Certainly the higher up you go in the like if it's just like a USB to CAN adapter, probably the easiest, right? But if you want to really make it as like chip to chip as possible, that's where you tend to go lower level protocols like I2C or SPI or UART, things like that.
And then, is it possible to use Swift? Are there any Swift libraries for the Nano?
Let me search real quick if there is a, because there's nothing really specific to the Nano about a lot of these libraries. It's just can the code build on ARM64, ARch64 architecture? And just a quick Google shows there is a bunch of Swift projects that, and actually there's even an official release for ARch64, it looks like. And a lot of this does benefit from the Raspberry Pi because that's an ARch64 also, and a lot of folks kind of want to get that stuff running. So if it works on that, it's very likely to work on this too. Worst case, you might have to rebuild it against the latest C runtime version in this version of Ubuntu or whatever, but a lot of folks, they think like, oh, you need like a specific version of things for the Nano, and that's really not true. It's just you might have to build it because it's ARM, and then it's really just the same. For example, like the PyTorch wheels that I build, I don't do anything special to those. I just, download the code and set some compiler options to turn on CUDA and cuDNN and things like that, and hit build and come back in 6 hours, and it's all just the same. It's just sometimes you have to actually compile things, whereas on x86, which is the incumbent platform, everything's already pre-built for the most part.
I aspire to be like you, Dusty, and be able to do a couple of things and hit build and come back 6 hours later, because
yeah, I've been doing that one for a while.
What you just said encapsulated like me pulling my hair out in a lot of ways sometimes. So
sometimes it depends, like if the project maintainer has a bunch of like x86 assembly in there, or they have AVX acceleration and they've never even built it on ARM, a lot of times that's where you might run into compilation problems because ARM is never a platform. But it's become exponentially more popular in the last few years, and most major projects now are building on ARM as well. Not even to mention, like, ARM server is becoming a lot more popular. So a lot of these HPC packages are also building on ARM. But for the most part, I mean, x86 code and ARM are completely compatible with each other. It's just if you start using these intrinsics or things like that where you might break some things. But far and away, it's mostly all the same type of environment.
I'm still gonna. So with you being so close to the community, and really, to be honest, being part of the community around the Nano community, but also your overarching NVIDIA machine learning community, what are some of those projects that are just blowing your mind right now? Do you have some examples that you can share with us?
Oh, sure, yeah. Well, so I mentioned Nemo earlier. It's this speech toolkit. So there's a productionized version of that called Jarvis, which is NVIDIA's smart ASR plus, it's like plus BERT and NLP and text to speech and all of that. And it has some amazing demos out there, and it'll be coming out in the future for a public release. But I encourage you to just to check the YouTube videos out of that, because when people think of AI, like conversational AI and like Hollywood movies and stuff, that's kind of like what this is. You see a lot of people with marketing like, oh, AI is just hype. There's a robot driving down the road or whatever, and that's not AI. It actually is. It's just laying this foundation to get up to something like this, where you're actually conversing with an agent that you might not even know is AI powered. So it's called conversational AI, and it's not unlike the Alexas or whatever, but just a much smarter, dynamic, intelligent version of those that can adapt to your conversation and things like that. So there's like a whole bunch of NVIDIA SDKs out there that handle all different parts of these artificial intelligence applications. Another really exciting one is the NVIDIA Isaac SDK. That's kind of our SDK for robotics and has a lot of exciting capabilities. I think just yesterday they launched this new end-to-end GPU accelerated reinforcement learning platform. So you can do, I think they took a benchmark that was doing, it was like a hand flipping Rubik's Cubes using reinforcement learning and solving those. And I think previously OpenAI ran that on a 384 node cluster that had like 6,000 CPUs. And the Isaac team, using this fully GPU accelerated pipeline, ran it on a single Ampere A100 times faster. So you went from a 384 core cluster that I don't know even how many megawatts that would pull, down to just one single PCIe card, and it actually trained multiple times faster at that. So that's really exciting for like grasping applications and these reinforcement learning agents that are coming along, because now it used to be you could still do the training on the GPU for reinforcement learning, but a lot of like the intermediary parts like the simulation or the reward function calculation, that was still on CPU. So you still needed a lot of CPU resources. Now it's totally on GPU. Along those lines with simulation, we have this really awesome simulator called Omniverse RTX, which uses the same ray tracing acceleration like you might see in the games. Like this Cyberpunk is all over the place now, and it's looked a gorgeous game, right? Well, now they have these simulators for the same thing, and what that means when you get photorealistic simulation, not to mention the very accurate physics, is that you can train your robot basically fully simulated and just deploy it into the real world. It's called sim to real. And why that's great is you can cover all these corner cases, like in self-driving cars. You can't just be out there testing all of the time. You want the car to be encounter negative situations, because otherwise, if it just collects real world data, you don't see that many instances of accidents or things like that. So in the simulator, they can simulate exactly what they need to, cover all of the circumstances that you might encounter, just transfer that model into the real robot. And since the imagery and physics and everything are totally accurate, it just kind of works because it's so close.
Sweet. Couple questions left before our time wraps up. One of them is, what is an AI/machine problem that seems close to the edge of the Nano's capability? Maybe before I jump to something like an NX. So, like, could I do a self-driving car with a Nano, or is that something that is beyond the capability? Like, I think that the viewer is trying to get at what is that line that I need to get that is drawn in the sand between something like the Nano versus upgrading to something a little more hardcore.
Yeah, good question. So I mean, with the self-driving cars, I'm gonna say car like like the Ducky Town or an RC car. Definitely can do those on the Nano, and for all intents and purposes could be a self-driving car. Real self-driving cars, they have much more powerful systems. Even the NVIDIA ones, it's like a Xavier plus a discrete GPU, and because they have like a whole ton of sensors. And that's really kind of where you see the differentiator is if you're doing like multiple 4K streams and like high-end inferencing on them, basically multi-model going on, like the self-driving cars, they run a whole suite of models, an ensemble. And it's going to do like lane detection. It's going to do collision avoidance. It's going to do pedestrian detection and like a ton of different models, segmentation to get the free space and path planning and all of this stuff. I think they have something like 20 different models running. So you need, a higher end processor if you're going to go to that extreme. But just like to get started and do the JetBot and things like that, the Nano's completely within its capability. On like we've been talking about the conversational AI and the speech recognition a bit. So Nano definitely can do the ASR. There's a whole bunch of speech recognition ones out there. On the NLP, running these big NLP models like BERT Large or GPT-2 or GPT-3, those do really push the limits and the memory bounds of what's available. I think like the BERT Large model itself is like 3 gigabytes. So if the model weights are 3 gigs and your memory is 4 gigs, you're kind of pushed to it. So, but those I was able to run incredibly smoothly on the NX, BERT Large. And it had a response time of like 10 milliseconds or something. It was like completely interactive. You would ask a question, it would run its query, and boom, back to you like that. What I did find is I could run the BERT, it's the small version of BERT, I'm blanking on BERT Base is what it's called. It's just like a simplified version of BERT. It still answers the questions quite as well. You're going to go from like 90% accuracy down to like 80% or something like that. And that does run on the Nano. So a lot of these like really bleeding edge models that are like billions of parameters, the big ones, that's where you might benefit from a step up. Or let's say you're doing like lots of camera streams. Folks that are doing like these self-driving robots for like the delivery systems or these precision agriculture, like another huge industry that's undergoing the self-driving car revolution is tractors and farming equipment. A lot of those would use like a Xavier-like system because they want 360-degree coverage. You want to stream like 6 or more HD or Ultra HD sensors, and at that point, it just makes sense how expensive the platform is, the actual robot that you're deploying, and then to take a step up. But I do encourage anybody, if you're like really into the Nano and what you've learned there, then the NX, it just has a whole massive amount of horsepower behind it. So I think the Nano is like 500 gigaflops. The NX is 20 teraops. So the NX can do accelerated innate processing. So it's just a massive increase in performance, but still in that little 15-watt form factor. So it's a really exciting SoC to work on.
Yeah, and if someone starts development or a project on like a 2GB or the original 4, how hard is it to take that project and like, let's say I start working on it and the scope gets to the point where I'm bumping up against that. Maybe I need that multi-video thread inferencing and a lot of that stuff. Can I take that and transfer that to an NX seamlessly, or is there going to be some refactoring that needs to be done?
No difference in a lot of the stuff that I run. Like, I build all these containers on the NX because they take, like, PyTorch takes 6 hours even on a fast machine. So I'll build that on the NX, but deploy it to both Nanos, CUDA libraries. They're all totally compatible. So the applications you don't really have to do any porting of it. That's a real big benefit of having this shared NVIDIA platform. And it's particularly helpful for these professional embedded designers who are actually making products, right? Because now it's called SWaP-C, size, weight, power, cost. It's a big factor in when you're designing actual devices and applications and platforms to be deployed, right? You have a specific power budget, you have a performance metric that you need to meet, and then there's a cost factor associated. Well, with all of the Nanos and the Xaviers and the other Jetsons out there that are all compatible together, you can pick and choose exactly which one that you want. And if you have a product line, let's say you have like your little robot and then a bigger robot and then the big one, and they all have shared software, and basically just plug the next one in there. In terms of adding more cameras and actually improving the functionality to take that step up, generally that is as simple as like adding additional threads to your program, or if you're using like the Python APIs for it, all that threading is handled under the covers, because Python itself at the interpreter level uses like the global interpreter lock, right? So your Python script is single threaded, but the stuff that it calls underneath in C++ libraries, that can be multi-threaded. So for example, my camera class, which has a Python binding for it, it runs in a C++ thread. So if you want to have 5 cameras, just make 5 camera objects in Python, and it will have launched 5 threads for you under the covers. And similar thing in like PyTorch, you specify the number of data loaders that you want, and that makes C++ threads that load them all. Otherwise, Python applications would just be single threaded, or there's some other ways of that you can use. Generally, it runs in different processes though.
Sweet. Good to know. I don't know how many projects I've outgrown, the dev board or SoC that I'm working on, and it's like, and you want to add this functionality, and I have to almost rebuild an entire project from scratch, which has been frustrating. So it's refreshing to see that approach from NVIDIA, where it's like I can truly pick and choose the appropriate module and SoC for that application, and that can grow. So that's always good to know.
The exact same projects and run them across all of them. Don't change a single thing, and it's just the frames per second that changes. And what's nice about the 2GB and the 4GB is you get the same runtime performance out of those. It's just a matter of memory capacity. So once everything's loaded in the 2GB, you get the same half teraflop of performance out of it. And like all of our examples and tutorials and the JetBot and everything all run just fine on the 2GB, which is great to see.
Perfect. So we're getting close to the end of time, but I think a question that everybody's interested in, since I have you, I'm going to ask the question of, what's up next for Jetson Nano? In terms of what you can tell us, what are you working on? What's Q1 and into the future look like for you guys?
Great question. Yeah, I mean, I wish I could speculate on the future of the future Jetson. It's by all intentions we intend to do future versions of it. It's still very much at a conceptual stage, so fortunately not anytime soon. So I would stick with the current product offering that that's out there. But we do have a roadmap that's online in terms of like when our SoCs are coming out and things like that. So the next one coming out after Xavier is called OREN, and will be a really great leap forward there. But that's still, you know, sometime out in the future, because the truth is, making these like advanced SoCs and stuff, it takes a long time, you know, even for a big company like NVIDIA that has, you know, world-class resources behind it. But, you know, we're always looking to improve things. And what's great about it is, you know, we are continually updating the software. So even since Nano's come out, it's had, you know, many new Jetpack releases, and with those comes new capabilities, new models that you can run. So we're continually staying on the cutting edge of what you can deploy to these devices that's out there in the community, and getting the latest PyTorch and TensorFlow so you can support the latest research and things like that.
Perfect. How about, I mean, what about content from you, Dusty? Is there anything that we can look forward to in the next couple months in terms of tutorials or anything like that?
Yeah, it's a good question. So, I mean, I recently, with the Nano 2 GB launch, recently finished up recording all these videos, and what I had added that was like an object detection training, so you can actually train your own object detector on the Nano, and even the Nano 2 GB you can train on, and there's been a lot of people doing that. So I've been thinking about maybe doing like a segmentation version of that. I'd always trained segmentation on my laptop because the data sets are much bigger, but there could be something to be said for doing a more limited model in there. I have a couple other, there's like an experimental folder in my repo that has a bunch of other ones. There's like this monocular depth model that's kind of been on the back burner for a while, but it does work really well. So it takes a camera image and then just inferences what the depth is from it. It's relative depth. So it's not like a stereo where you're going to get like a centimeter measurement out of it, but it is very useful. Like if you want to do some depth perception just from a cheap webcam or whatnot, you can actually infer a depth model out of that. And then in the broader scale, I've been thinking, like, for a long time now, we've been doing the classical classification, the detection, the segmentation, and other robotics. So I've been kind of thinking, what else can we do? Like this, the conversational AI stuff is coming soon, and you can try it through Nemo, but other things for like smart home or DIY things, like I mentioned, that guy doing the power prediction system earlier, maybe looking more into like the signal processing networks, or those are already out there, but just not quite as popular as these video applications. So if you guys have any suggestions, you know, I would love to hear it, and you can hop on my GitHub or the forums and message me. My email's on there too. So I'm happy to collaborate and hear where you guys find things useful and want to go with things.
Perfect. Well, Dusty, thank you so much for your time on this Friday. I know it's highly valuable for both yourself as well as NVIDIA. So again, thank you so much for hanging out with us for the hour. For those of you watching, I hope that we answered at least most of your questions. If you were looking for more information, both NVIDIA's website, I know Dusty's on the forums, and some other information that we'll be sharing out as well. You can also jump on the SparkFun website as well. We'll be sharing those links out for you. So thank you so much, Dusty. Again, you're like my machine learning sensei. I feel like I'm taking notes half the time and not necessarily being on video. So thank you again, and hope to speak to you soon.
Thank you, Derek. Yeah, this was great. This was a lot of fun. If you guys want to do this again sometime in the future. So this is like my favorite thing, just chatting. So really appreciate it.
Yeah.
Thank you.
Not a problem. With that, I think we're done. We're going to wrap, and we'll speak to all of you soon. Enjoy your weekend.